Hey everyone, welcome back. Now that we've talked about what externalities are when costs or benefits fall on third parties, next up we're going to talk about how to graph them. And so in doing that, we need to distinguish between the private and the social element of both costs and benefits. So we'll talk about private marginal cost and social marginal cost. So I will label these marginal cost private and marginal cost social. And then we'll also talk about marginal benefits, right? And there are private marginal benefits, which we'll delineate as marginal benefit private, and social marginal benefits, which we'll label as marginal benefit sub S, right, for social. And the social aspects of these are the cost to everyone, that is to the decision makers, right? The people making the decisions, the people undertaking the actions or making the contract or the deal, as well as everyone else. So the social costs are the benefits to the private parties. The social costs are the cost to the private parties plus the external costs that fall on third parties. And the same with the benefits. Right? Social benefits are made up of private benefits plus external benefits. I think that'll become clear as we start doing some graphing. So let's look at a classic case of a negative externality. And so we're going to draw what is basically our traditional supply and demand graph. There we go. Except we're going to label the price axis a little more specifically, and we're going to label it marginal benefit and marginal cost. But those are basically price measurements. And the horizontal axis we'll still label with Q, right? This is the quantity of the activity that we're talking about. So we'll look at the market for electricity from fossil fuels. Because this is a classic example of an action that we undertake that generates external costs in the process. Right? So burning coal or even natural gas, although to a much lesser extent, to generate electricity does impose costs on the larger environment, right, that are not borne directly by the power company, and they're not borne directly by the consumers unless there's some public policy that moves that cost to them. So now, instead of our traditional supply and demand, we're going to think in terms of private and social marginal benefits and marginal costs. So electricity is very valuable, right? We use it for lighting and heating and for producing things and running computers and for transportation, right? So electricity has a lot of values. We're going to graph that as the private marginal benefit from electricity. Right? This is basically the demand curve, right? The demand is based on the marginal benefit, the perceived marginal benefit of a good or service to the consumer. And now Duke Energy or RG&E or whatever power company is producing the electricity, they have an upward sloping, basically supply curve, but this is really based on the private marginal cost of production. Right? What is the cost to them to buy the fuel, to build and maintain the generating facility, to employ the people necessary to generate the power and maintain the grid through which it's distributed? Those are private costs of production. And if that's all we think about, right, then there is some equilibrium here where the benefit of the last unit produced is equal to the marginal cost of producing it. And that gives us what we call Q star private. So Q star private represents the intersection of the private marginal benefit and the private marginal cost. So if the parties to this transaction, right, the interested parties, the people who want to buy electricity, that's many of us, all of us probably, and the power company that's willing to produce it, there's a market clearing equilibrium here. And then there's a corresponding price of electricity. We could jot that in as well. That's less important to some extent for our purposes right now, but it is relevant. Now, what are we missing? What we're missing is the cost that generating electricity imposes, right? By burning coal, for example, or other fossil fuels. To what extent does that impose costs on the larger environment and everyone in it, both, plants and animals and other people, right? So those costs are in addition to the private marginal costs. And so those are external costs. We can add those on top. So we could add the external costs on here, the negative externality or the external cost. What just happened there? Put it back. The external cost, if we add that on top of the private marginal cost curve, and then we add them together, we will get the social marginal cost curve. Right? So the social marginal cost curve is made up of, who makes up society? All of the electricity consumers and all of the electricity producers and everybody else. Right? To the extent that other people and other creatures are affected, then those are the external costs. And so when you add them together, you get the private costs plus the external costs to find the social costs. And then the interesting thing here is you look for where those intersect. Where is the marginal benefit of the last unit of electricity produced just equal to the full cost, right? The social cost of producing it? Well, that's over here. And this gets back to the example about the driving and the speed limit, right? It's not that we're going to say, these external costs are terrible. We should not have any electricity. Electricity is immensely valuable, right? So we acknowledge the value of the electricity, but we're saying we should consider the full social cost, right? The cost to Duke Energy or RG&E or some other power company, as well as the costs, other costs on society. And so when you factor those in, the optimal output level, for electricity is not necessarily zero, but it's also less than Q star private. And that's what we can see here, right? That the socially optimal output level is less electricity. And how do we ration less electricity among, all the people? Well, ultimately it would cost more, right? There would be a higher price for that electricity. And so the problem from not incorporating, not internalizing or addressing those external costs is that we have a problem with overproduction, right? The private parties overproduce and overconsume, right? And the extent of the overproduction is this difference between Q star private and Q star social. The other thing we can identify here is that society is made worse off, right, when this happens. Because every time when we get to Q star social, right, the marginal benefit of the electricity, I could highlight on these blue dots, right, and the full social cost, right, is on the pink line, right? The blue dot's on the pink line. And when we get to this point, that blue dot, it's efficient, right? The marginal benefit of the last unit produced is still equal to the full cost, including the external cost, right? The costs on the environment. But when we go beyond that, people are enjoying, they're getting values for electricity, right, that are in this section right here, right, that I'll highlight in that orangish yellow color, right? That's the benefit of those last units of electricity. And the full cost of those last units is shown on the pink line, right? And so society is made worse off by this amount right here. And so the area of this rectangle right here, we refer to as a deadweight loss. So this is a deadweight loss to society because we are incurring societal costs that are greater than the benefit of those units produced between Q-Star Social and Q-Star Private. So that's the deadweight loss from overproduction. So there you go. And that, in a nutshell, is the graph that shows a negative externality, right? Because we're splitting out the cost. There's a private marginal cost and a social marginal cost. And you can see that because Q-Star Private is greater than Q-Star Social, there's an issue with overproduction and an associated deadweight loss. So there you go, negative externality. Let's do one more graph for the positive externality, and then we'll take a quick break. So for a positive externality, actually, you know what, I should label these two, right? So this is the negative externality graph. The negative externality graph. Now we'll do a positive externality graph. I'll put this in the corner. I'll write it the right way here. Positive externality graph now. I started to draw the graph here, right? On the vertical axis, we'll have marginal costs and marginal benefits. On the horizontal axis, we'll have the quantity. And so this time, let's just stick with something really easy. I think earlier I mentioned landscaping, right? If people put in a lot of beautiful landscaping, that benefits them. The main reason we take care of our lawns is because we want our lawns to look nice, right? That we enjoy it. It makes our house look nice. So there is a marginal benefit private, right, to landscaping your own house. And of course, there is a cost to that, right? The more landscaping I install, the more expensive it gets. And putting in a lawn is expensive. Adding additional plantings is probably a higher marginal cost. Adding additional flower beds or gazebos or fountains, right, is the more landscaping you put in, the more expensive it gets. And so most of us stop at the point where the private benefit and the private cost become equal, right? We realize that the marginal benefit is subjective, right? Some of us enjoy like the beauty of the landscaping more than others, or even just the pride of having the beautiful house on the street, whatever it is. Here is Q-Star Private. But that accounts for the benefits to us and the cost to us, right, as a homeowner. Now, what's missing here? Well, whenever I walk through a neighborhood that's particularly well-maintained and particularly nice, it makes me happy, right? It's a nice place to go for a walk. It's a nice place to walk your dog. It makes people smile, right? Beautiful flowers, nice scents from the herb gardens, whatever it is. There might be benefits that accrue to other people who are enjoying your nice landscaping. At a more monetary level, if your house is on a street with other nice houses that are well maintained, that affects your property value, right? Whenever your neighbors' houses are nicely maintained and nicely landscaped, that makes your house more valuable. That's an external benefit. And so if we add those external benefits in here and we say, all right, yeah, most of the benefits of landscaping accrue to the individual homeowner, but there are external benefits, then there might be a marginal benefit curve, or there will be a marginal benefit social curve that is above the private one, right? And the difference between these, let me enlarge it so I can write it neatly. These are the external benefits, or the positive externality. So where I write external benefits, you could write positive externality up above, or if I wrote negative, did I write negative externality or I wrote external costs, that's also the negative externality up there. Right? So there are external benefits, right? There are benefits that fall on third parties. You could have graphed, immunizations here, right? What's the main reason that we get immunized or we immunize our kids? It's to protect them from, certain contagious diseases. But there are external benefits to that, right? When most people are immunized, that keeps everyone safer, because if people can't catch those diseases, then they can't carry them and spread them to others. So you could a graph for immunizations would look, very similar to the one for landscaping. So the socially optimal output level, right, the socially optimal level of landscaping is in fact higher than the private one. So this is a case where in the case of positive externalities, we're concerned that the private parties may underproduce. May underproduce goods with positive externalities, right, with external costs. And it's this distance right in here. So the potential level of underproduction is right there. And because of that, society misses out on certain benefits, right? We stopped landscaping here at Q Star Private, but in fact at Q Star Private, the full social benefit of landscaping is still higher than the marginal cost of that landscaping, right? And that is the case all the way up to here. And so this area in here, this is a potential deadweight loss from underproduction. So there you go. Those are the two main graphs that we use to look at externalities. One for positive externality, that's this graph. Landscaping, immunizations, right? Other things that like beautiful music, in the subway station, whatever it is. And then the graph for negative externalities that we did before. The next thing we have to talk about then is well, what do we do? What kind of policies do we use to address those? We'll pick that up in another short video.